When it comes to SpaceX launches, Starship is always the star of the show. It's massive, it's ambitious, and it grabs all the headlines. But here's the thing. While everyone's eyes are on the rocket, few people realize there's an entire world of cutting-edge engineering happening right underneath it. And trust me, it's just as epic. Right now, one of the most impressive projects at Starbase is the brand new double-flame trench system being built at Pad B. It's a bold, innovative piece of infrastructure, and it features some unique design elements, unlike anything we've seen before. Let's break it all down right here in today's episode of Alpha Tech. After months of focusing on building an entirely new structure for Pad B, we now have a much clearer look at this flame trench project. From what we've observed, SpaceX's progress currently sits at around 80% completion of the main frame for the trench. 5 supports for the flame diverter have been set into place, followed by 2 massive flame buckets. Alongside those are smaller components like several water pipes and distribution lines that will supply both sides of the flame trench. These will connect to the existing water outflow pipes, which currently end beside the tower, running through the sheet pile wall, an open gap, and then through the trench's steel walls to supply both distribution lines beneath the trench's overhang. It's genuinely fascinating to see the internal workings of a structure like this before it's fully completed, especially since once it's finished, the exterior tends to look much simpler than what's going on inside. With rapid assembly moving ahead, this massive project is expected to be completed in about 2 months, and Pad B will officially be brought online for Starship launches by the end of the year of 2025. As this development unfolds, many people have also started to wonder what the future holds for Launch Pad A, the site that's been through countless ups and downs with Starship. After Starship's very first launch, SpaceX's one-of-a-kind launch pad was nearly obliterated, an unforgettable image that marked a turning point and sparked major upgrades. Although the current donut-shaped launch mount has performed better since then, thanks to a steel plate mat and a water deluge system beneath it, it's still not seen as a long-term solution. That's precisely why the flame trench at Pad B is rising as a star option. And once it's operational, Pad A is widely expected to undergo changes to keep up with Starship's future high-cadence flight schedule. There's been plenty of speculation about Pad A's fate. Some believe SpaceX might plan to upgrade Pad A by constructing a flame trench to replace the existing donut mount. However, this scenario also comes with complications that give us pause. If SpaceX were to dig a flame trench here, they'd face a tough location. It's hemmed in by a massive tank farm and fueling infrastructure. Moreover, Pad A wasn't originally built with a trench in mind, so digging one now would mean cutting through a dense web of underground pipes, cables, and foundations, potentially disrupting ongoing operations. Some in the community have voiced opposition to this approach too. They argue that trying to retrofit Pad A with a flame trench might be a half measure, one that improves exhaust management, but doesn't fully address the pad's vulnerability to frequent, high-power launches, especially if SpaceX moves toward daily Starship operations in the future. So, if building a flame trench isn't an option, SpaceX might end up dismantling Launch Pad A and using it solely for catching rockets. Well, this prediction actually makes a lot of sense. Until SpaceX has another operational tower, Tower A still serves as a backup option for catching boosters, buying time for the main tower to be cleared and prepped to catch the returning Starship's second stage. Of course, Tower A isn't expected to stick around forever either. It was built on an older design, and with the increasingly larger, more powerful versions of Starship, Tower A is starting to be considered outdated. That's why it's almost certain that in the future, another new tower will rise at Starbase, taller, stronger, and built to the updated specs based on everything they've learned at Pad B. A major overhaul could solve the long-term demands, but it would come at the cost of a significant operational pause. Is there any other scenario that could happen to Pad A beyond what I've just outlined? I'd love to hear your take. Drop your thoughts in the comments. Don't forget to give us a subscription if you find the video useful. But regardless of what option SpaceX chooses after August, it's expected they'll shift most of their focus away from Pad A and pour their energy into Pad B more than ever before, because by then, the flame trench will have its entire structure completed. So, when the flame trench finally comes online, what issues will it solve? And what new challenges will it create for SpaceX to tackle? First up, the clear advantages this structure brings. The primary use of a flame trench is to safely channel and dissipate the extreme heat, pressure, and exhaust gases produced during a rocket launch, protecting the launch pad, rocket, and surrounding infrastructure. When a rocket's engines ignite, they generate plumes exceeding 3,000 degrees Celsius, with thrust forces ranging from hundreds to thousands of tons. The trench directs this fiery exhaust away from the launch platform through a reinforced concrete channel, often 10 to 20 meters deep and lined with refractory bricks to withstand thermal erosion. A deflector, typically steel or Inconel, redirects the plume horizontally, reducing recoil damage by up to 60%. This ensures that the company will be ready when launching future Starship variants with thrust many times greater than the current version, while the infrastructure will still be able to perform its job reliably. In addition, the flame trench features a water deluge system capable of spraying between 50,000 and 1 million liters per launch. It cools the trench, absorbs the extreme heat flux, around 10 to 20 megajoules per square meter, and reduces acoustic energy by 30 to 50%, preventing structural cracks or instability of the rocket. A great example of this system's value is NASA's Kennedy Space Center, where the flame trenches allowed the Saturn V to launch safely through dozens of missions. Beyond this core function, the flame trench also plays a supporting role in maintaining safety and efficiency during launches. It helps contain debris and hazardous exhaust gases, like hydrochloric acid from solid rocket boosters, within a controlled area, making post-launch cleanup much easier. The drainage systems inside the trench remove water and leftover debris, ensuring the pad remains operational. These trenches also improve launch cadence. Once operational at SpaceX's Pad B in Boca Chica, this flame trench infrastructure is expected to enable rapid turnarounds for Starship's reusable boosters, potentially cutting refurbishment time by up to 70% compared to pads without a flame trench. However, while flame trenches provide significant benefits, not all are built the same way. Different organizations have approached flame trench design in their own unique ways. NASA's Kennedy Space Center's Launch Complex, 39 LC-39, built for the Saturn V and later modified for the Space Shuttle, features 2 flame trenches per pad. Each trench is 18 meters deep, 15 meters wide, and 137 meters long, constructed with high alumina concrete, boasting a compressive strength of 50 megapascals. They use 45-degree steel flame deflectors to split the rocket's exhaust plume into 2, reducing recoil force by 60%. The site's high-capacity water deluge system pumps 450,000 liters per launch, cutting heat flux to the pad by 90% and reducing acoustic energy by 50%. This dual trench setup, which cost $30 million in the 1960s, was ideal for extremely powerful rockets like Saturn V, 3,400 tons of thrust, but required heavy maintenance after repeated launches due to surface spalling. On the other hand, SpaceX's Starship launch pad at Boca Chica, Texas, is tailored for a different approach. Designed to handle the immense 7,500-ton thrust of the Super Heavy booster, it features a single, wider trench, around 20 meters deep, 25 meters wide, and 100 meters long. Its flame deflector is a curved Inconel 625 plate, water-cooled through copper-lined channels, capable of handling exhaust gases exceeding 3,000 degrees Celsius from 33 Raptor engines. The trench lining uses zirconia-coated refractory bricks over high-strength concrete, reducing erosion to just 0.1 millimeters per launch compared to NASA's 0.5 millimeters. SpaceX's water deluge system, capable of spraying up to 1 million liters, leverages advanced computational fluid dynamics to minimize water waste, making it about 20% more efficient than NASA's system. In the end, this infrastructure will stand as an engineering achievement no less exciting than Starship's upcoming flight tests this year. It's impressive how SpaceX is managing to balance the simultaneous challenges of building a complex flame trench while continuing to manufacture and refine Starship. But, after all, constructing such a system is no easy task. Building a flame trench demands overcoming formidable obstacles, as it must endure the punishing heat, pressure and vibrations of rocket exhaust and acoustic energy akin to a small earthquake. The first and perhaps most critical difficulty lies in material selection and fabrication. The trench's core structure, typically composed of high-strength concrete, must be formulated to resist extreme thermal shock and spalling from rapid repeated temperature fluctuations. Achieving this requires a carefully engineered mix incorporating high-performance aggregates like basalt, quartz, or high alumina cement. Even minor impurities or inconsistencies in aggregate grain size can significantly reduce durability, leading to surface degradation after just a handful of launches. To further protect the trench, the concrete is lined with high-temperature refractory materials. These linings, whether made from dense alumina silica bricks, zirconia-based coatings, or castable ceramics, must tolerate sustained exposure to temperatures between 1,800 degrees Celsius and 2,500 degrees Celsius, while keeping erosion rates below 0.2 millimeters per launch. Manufacturing these refractory components requires specialized kilns, tight quality control, and custom molds tailored to fit the trench's unique geometry. Any inconsistency could result in localized erosion or failure points, threatening the trench's long-term integrity. A particularly notable example is SpaceX's Boca Chica Flame Trench, where the centerpiece is a massive flame deflector plate made from Inconel 625, a high-nickel superalloy prized for its exceptional resistance to heat, oxidation, and mechanical stress. Though capable of withstanding temperatures over 1,000 degrees Celsius, Inconel 625 is notoriously difficult and expensive to machine, weld, and fabricate at scale. Months of iterative prototyping, stress testing, and computational simulations were necessary for SpaceX engineers to perfect the deflector's thickness, curvature, and water cooling channel arrangements. Even then, achieving reliable welds and preventing thermal fatigue cracks required cutting-edge metallurgical techniques. Structural design introduces another layer of complexity. The geometry of a flame trench must precisely balance exhaust flow dynamics, site constraints, and safety margins. Trench width, depth, and deflector angles must be optimized to guide hot exhaust gases away from the rocket and support structures while avoiding dangerous back pressure or lateral shockwave reflections. This is where advanced computational fluid dynamics, CFD modeling, becomes indispensable, simulating how high-velocity exhaust streams behave in confined spaces at hypersonic speeds and extreme temperatures. Any miscalculation in this process could lead to catastrophic outcomes. Historical examples, such as the early Soviet N-1 rocket launches, demonstrated how poor trench geometry amplified acoustic shockwaves, resulting in devastating pad explosions that set back entire space programs. Integrating cooling and drainage systems is equally daunting. Water deluge systems must be engineered with precision, placing nozzles, distribution pipes, and control valves at calculated intervals to blanket exhaust zones effectively while withstanding corrosion from acidic byproducts like hydrochloric acid, HCl, produced by solid rocket boosters. These systems can involve hundreds of thousands to millions of liters of water per launch, demanding redundant pumps and high-capacity storage tanks. In short, constructing a modern flame trench is a highly interdisciplinary endeavor, combining materials, science, fluid dynamics, structural engineering, acoustics, and metallurgy. Every component from the trench lining to the deflector plate to the water deluge system must work in seamless coordination under some of the harshest conditions imaginable. It's a testament to how much behind-the-scenes infrastructure is required just to make those few fleeting minutes of a rocket launch possible. And as SpaceX pushes toward higher thrust Starship variants and faster launch cadences, the importance of such robust, carefully engineered trenches will only grow, setting new benchmarks for spaceflight infrastructure around the world. While everyone in the space community is focusing their attention on the next Starship flight, Starship Flight 9 being busily prepared by SpaceX at Starbase, few know that at the tip of Florida's coast, the company is far from idle. They are busy constructing a new facility that could leave us amazed. What is it? When will SpaceX's third Starship launch facility become operational? When it comes to one of SpaceX's most important Starship launch sites, besides Starbase in Texas, we can't overlook Launch Complex 39A, LC-39A in Florida. Although development activities for Starship began later there, Florida has always been mentioned, especially by senior SpaceX officials, including Elon Musk, as a potential primary launch site for future Starship missions to the Moon and even Mars. Meanwhile, Starbase is expected to eventually serve primarily as a test facility. However, despite 4 years of Starship development, LC-39A has seen relatively little visible progress, leading many to question the company's earlier statements. But in reality, it's not that nothing has changed at LC-39A, it's just that the changes have been so few and spaced out over such a long period that they haven't attracted much attention. In 2022, the first Mechazilla Tower was erected in Florida, sparking hopes for the first Starship launches from the site. Following that, fuel storage tanks were installed, and support structures similar to those at Starbase's Pad A began to appear. Everything seemed to be progressing smoothly, but by early to mid-2023, visible activity slowed significantly. Then, in early 2024, SpaceX began dismantling some of the support structures. This came after the Starship IFT-1 and IFT-2 flights, which revealed that the launch pad setup at Pad A was perhaps not as effective as anticipated. At that time, many speculated that infrastructure development in Florida would quickly ramp up, but reality hit hard when progress remained stagnant for months. Only recently has there been a clear sign of renewed activity at LC-39A. In the past few weeks, excavation work and pile driving have been in full swing, and a large tank that was previously installed behind the tower has been removed. This suggests that SpaceX may be implementing a new design to replace what was previously built. From this, it's clear that everything happening at LC-39A is closely modeled after what's been developed at Starbase. And true to the nickname passed around the community, Starbase is functioning as the development hub, operating at full capacity to deliver proven solutions that can be implemented in Florida. This helps ensure that when launches from LC-39A do begin, they won't pose any risk to the surrounding ground infrastructure. So, the big question is, what exactly is SpaceX building now? Well, just as many people are thinking right now, what SpaceX is building appears to be a flame trench similar to the one currently being completed at Pad B. A flame trench is a critical piece of launch infrastructure, a deep concrete-lined channel designed to redirect the intense heat, pressure, and exhaust plumes generated by rocket engines during liftoff. This protects the launch pad, surrounding facilities, and the rocket itself from damage. For Starship, which represents a leap in scale and thrust compared to previous rockets launched from LC-39A, a flame trench may be necessary to meet these engineering challenges and ensure the site's longevity for frequent missions. This makes perfect sense for the Starship system. When paired with the Super Heavy booster, powered by up to 33 Raptor engines, it produces about 17 million pounds of thrust at liftoff. That's nearly twice the thrust of the Saturn V, 7.6 million pounds, which originally launched from LC-39A and well beyond the Space Shuttle, about 7 million pounds with solid rocket boosters, and even SpaceX's own Falcon 9 and Falcon Heavy, 1.7 and 5 million pounds respectively. The massive exhaust from 33 methane-fueled engines generates extreme heat, pressure, and acoustic energy. If not properly managed, this can erode the launch pad, scatter debris, and reflect destructive forces back onto the rocket. Additionally, SpaceX's experience at Starbase in Texas highlighted the importance of a flame trench for Starship. During the first orbital test flight in April 2023, the Starbase pad lacked a flame trench and relied on a basic launch mount. The result was catastrophic damage. A crater formed beneath the pad, concrete chunks were blasted outward, and nearby infrastructure was affected. This led SpaceX to install a water-cooled steel plate and Deluge system to mitigate the impact of the exhaust, though these were seen as temporary fixes. Reports that a flame trench is now being constructed at Starbase suggest that the traditional approach is seen as more sustainable for handling such powerful launches. SpaceX is planning a high launch cadence at LC-39A, over 44 launches per year, according to the 2024 Environmental Impact Statement, including Starlink deployments, Artemis lunar missions, and eventual Mars flights. A flame trench would protect the pad. Channeling exhaust away reduces wear and tear, supporting repeated launches. Mitigate acoustic energy. A trench lowers the risk of reflected sound waves damaging the vehicle. Enhance safety. Proper exhaust management prevents debris and heat from affecting the rocket or crewed missions. However, building a flame trench at LC-39A isn't straightforward. The site's high water table and marshy terrain complicate deep excavation, likely requiring an above-ground structure or significant groundwork consistent with the observed construction efforts. Early Starship plans for LC-39A, outlined in a 2019 environmental assessment, proposed a flame diverter, a metal structure to redirect exhaust instead of a trench. Yet, the shift toward a trench suggests SpaceX now favors a more robust, traditional approach for this operational hub. At this point, many are asking, when will the Florida launch pad actually become operational? Honestly, that depends on the ongoing tests at Starbase. Only when Starship can reliably perform all phases of launch and landing at Pad B will SpaceX begin using the Florida site, ensuring no risk of damage to the surrounding ground infrastructure. Meanwhile, the flame trench system at Starbase is also progressing rapidly. All development work at Pad B is being carried out in parallel, from refining the Mechazilla tower to installing the flame trench, the launch mount, and the liquid fuel delivery systems. In fact, the continued testing and development of both the launch mount and flame trench show that Pad B is moving toward operational readiness, even though no official completion date has been confirmed yet. Still, it likely won't be long before we see it in action. Beyond developments in the Starship program, SpaceX has also made headlines in the commercial launch industry. Just recently, the U.S. Department of Defense awarded launch service contracts to SpaceX, United Launch Alliance, ULA, and Blue Origin, marking the first time all three companies will share responsibility for launching high-priority military and intelligence payloads. Announced on April 4th by the U.S. Space Force's Space Systems Command, the contracts are part of the National Security Space Launch, NSSL Phase 3, Lane 2 procurement. This key initiative is designed to strengthen the Pentagon's access to space for its most sensitive and mission-critical operations. SpaceX emerged as the leading contractor, securing $5.9 billion in projected awards. ULA followed closely with nearly $5.4 billion, while Blue Origin was awarded nearly $2.4 billion. Collectively, the three providers are expected to carry out 54 launches between fiscal years 2025 and 2029. A robust and resilient space launch architecture is the foundation of both our economic prosperity and our national security, said General Chance Saltzman, Chief of Space Operations for the U.S. Space Force. Of the 54 anticipated missions, SpaceX is expected to perform 28, roughly 60%, with ULA handling 19, around 35%. Blue Origin, which has flown its New Glenn rocket only once and is still awaiting certification, is slated for 7 launches beginning in the program's second year, contingent on its vehicle being certified. The Lane 2 phase focuses on complex, high-stakes missions to high-energy orbits, requiring heightened levels of mission assurance. These include missions supporting secure communications, missile detection, and other critical national defense objectives, making this the most demanding category in the NSSL program. Missions are typically assigned 2 years before launch, with flights under the new contracts expected to begin in fiscal year 2027 and run through 2032. The inclusion of Blue Origin reflects a significant shift in the Pentagon's strategy, fostering increased competition among U.S. launch providers. Since Phase 2 contracts were awarded in 2020, SpaceX has dominated the national security launch market. This marks the first time the Department of Defense has designated 3 primary launch contractors. Blue Origin was selected as the third best value provider, despite New Glenn still awaiting certification for national security missions. However, Space Force officials have expressed confidence in the rocket's progress, anticipating it will meet certification requirements before its assigned launches begin. ULA, a joint venture between Boeing and Lockheed Martin, recently hit a major milestone with the March 26 certification of its long-delayed Vulcan rocket. The company plans to begin flying its previously awarded Phase 2 missions later this year. All three launch providers will be required to meet rigorous mission assurance protocols, including integrated planning and coordination with government teams to ensure mission success. Missions under these contracts will be awarded annually, with the first set of fiscal year 2025 launches to be announced later this year. Assignments will continue each October through the end of the contract term. However, it's clear that SpaceX remains the top priority launch partner for the U.S. Department of Defense. After all, SpaceX rockets continue to lead the industry in both reliability and rapid deployment capabilities. Recently, a mission originally assigned to ULA was transferred to SpaceX by the U.S. Space Force in an effort to reduce the growing backlog of satellites awaiting launch. The GPS-3 SV-08 satellite, the eighth in the GPS-3 constellation, is now scheduled to launch no earlier than late May aboard a SpaceX Falcon 9 rocket from Cape Canaveral Space Force Station in Florida, according to an April 7th announcement from the Space Systems Command. This marks the second recent GPS mission reassigned from ULA to SpaceX. Last year, the GPS-3 SV-07 satellite was also moved from a planned late 2025 ULA Vulcan launch to a SpaceX Falcon 9, which successfully lifted off on December 16th in a mission named Rapid Response Trailblazer. To maintain a contract balance between launch providers, the Space Force noted that a future GPS launch previously allocated to SpaceX will be reassigned to ULA. ULA's Vulcan rocket, which was recently certified for National Security Space Launch (NSSL) missions, has experienced development delays and now faces a growing backlog of military payloads under the NSSL Phase 2, contract awarded in 2020. Regarding the SV-08 launch, Colonel Jim Horn, Senior Materiel Leader for Launch Execution at Space Systems Command, stated, "This launch executes a vehicle trade, moving the GPS-37 mission from Vulcan to a Falcon 9, and swaps a later GPS-3F1 mission from Falcon Heavy to Vulcan. It showcases our ability to launch in 3 months, compared to the typical 24-month time frame. 430, that's the number of Falcon 9 landings so far, an achievement no other rocket on Earth can match. And this all thanks to its legs. Currently, SpaceX is developing the Starship HLS version, and it makes perfect sense that they're reusing concepts from Falcon 9's landing system. This approach isn't just useful for launches on Earth, it's also key for future missions to the Moon and even Mars. It also means that Starship will no longer depend entirely on Mechazilla to land. So, how does SpaceX do that? One of the biggest upgrades for Starship in 2025 is its leap toward full reusability. Super Heavy's already pulling off precision landings with Mechazilla, but SpaceX is going a step further. They're adding landing legs to both Super Heavy and Starship. This gives SpaceX two options: catch both stages with Mechazilla, or let them land on their own legs. It's all about having more flexibility, cutting down costs, and making sure they can land safely no matter where they are, from launch pads to remote terrain. The idea of landing with legs for the whole vehicle is part of several different projects at SpaceX. For example, the cargo version, developed for the Department of Defense, would make it a fast, high-capacity transport vehicle for military goods during exercises or in real-world conflict. With its legs, it could land on flat surfaces, carrying more cargo and faster than a traditional military transport aircraft, like the C-5 Galaxy or KC-390 Millennium. Additionally, for the Artemis III mission in 2027, the Starship HLS will also need landing legs to safely land on the rugged, rocky surface of the Moon, ensuring the vehicle stays balanced despite the challenging terrain. What's more, SpaceX already has experience with Falcon 9, a rocket capable of landing using 4 legs that fold up during launch and deploy before touchdown. So, the logic was simple. If it works with Falcon 9, why not try it with Starship? But the truth is, it wasn't that simple. There were plenty of technical barriers that came up when trying to transfer Falcon 9's landing leg design to Starship. The first problem is that Starship is a whole different beast compared to Falcon 9. Without the booster, Starship is about 171 feet tall with version 2 and weighs around 1,600 tons when fully fueled, way heavier than Falcon 9, which stands at 230 feet and is much lighter. The landing legs on Falcon 9 are built to handle around 20 to 30 tons during landing, but with Starship, that number jumps to over 100 tons in dry weight. And it gets even heavier if it's carrying cargo, or a crew. So, the big challenge here is making sure the landing legs are strong enough to handle all that weight without bending or breaking, while still keeping the whole vehicle stable. Second, Falcon 9's landing legs weren't built to handle rough terrain. If Starship used the same design, it could easily tip over when landing on uneven surfaces like beach sand, or even the Moon or Mars. So, the new design upsized the foot pads to spread the weight over soft ground, like lunar regolith, so it won't sink in. Falcon 9 didn't need this, so SpaceX had to test new ideas, like wider legs or even ones that can self-level. They also had to think about the Raptor engines blowing dust around during landing, which could erode the ground beneath the legs. That meant the legs had to be strong enough to handle more vibration and wear, while also dealing with heat from the engines without getting damaged. The final issue concerns Falcon 9's folding mechanism, which isn't strong enough for Starship due to the significantly higher aerodynamic forces during launch with the Super Heavy booster. SpaceX tested fixed or semi-fixed leg designs, but these only added complexity and weight without providing the needed stability. That's when they turned to the Mechazilla system to catch Starship instead. But nothing's impossible, especially with Elon Musk at the helm. He's all about tackling what others think can't be done, like catching a booster with chopsticks, which worked. Creating landing legs for Starship is no different. It's just a matter of time. There's one detail that suggests SpaceX is quietly working on a landing system for Starship. A photo taken from outside Starbase shows a mechanical joint mounted on the vehicle, something that looks like a hinge or folding mechanism. It strongly resembles part of a landing leg system that would fold into the body during launch and deploy during landing. Of course, that's just my guess. What do you think this part could be? Drop your thoughts in the comments. Alright, to overcome the challenges of designing landing legs for Starship, the new legs will likely need a completely different mechanism from what we've seen on Falcon 9. With the current design, Falcon 9 has 4 landing legs, while Starship versions like the HLS usually have 4 placed around the vehicle. Since it's built to land on the Moon, where there's no atmosphere, they don't need flaps for aerodynamic control during re-entry. So they went ahead and removed both the alt and forward flaps completely. Each Starship variant has a different landing leg design, tailored to where it's meant to land. Take the HLS, for example. It's built for the Moon, where gravity is about 1/6 of Earth's. That means the landing legs don't need to handle as much force as something like the cargo Starship, which has to survive touchdowns back here on Earth, where the gravity's way stronger. Because of that, the cargo version needs beefier legs with shock absorbers or some kind of damping system to spread out the impact. Those legs might need to handle anywhere from 800 to 1,500 tons, depending on how heavy the ship is during landing. HLS, on the other hand, still has shock absorption. It might use hydraulic pistons or crushable materials like aluminum honeycomb to soften the landing. But here's the key difference. Its legs need to be longer and adjustable, like telescopic legs, to deal with the Moon's rough and uneven surface. Say one leg touches down in a crater. It can extend to keep the whole ship level, and since the Moon's surface is full of rocks, slopes, and dust, those legs have to be smart too. We're talking wide footpads to stop the ship from sinking, plus sensors that scan the terrain in real time and adjust the legs as needed to make sure everything stays stable. Also, in low gravity, like on the Moon, things get tricky fast. There's a real chance the whole ship could tip over, especially if it's landing on uneven rocky ground that's jagged and unpredictable. That's exactly why SpaceX spaced the legs out nice and wide, then reinforced them with a solid, sturdy design. It's all about creating a strong, stable base that holds firm, no matter how rough or unpredictable the terrain gets. Finally, the materials used need to be both lightweight and incredibly tough. They've got to handle the brutal lunar environment, extreme temps from negative 173 degrees Celsius to 127 degrees Celsius, cosmic radiation, and even thermal expansion, which could throw the whole thing off balance if not managed properly. That's how the landing legs are designed for the Moon. But when it comes to Mars missions, things get more complex. While SpaceX hasn't officially revealed the landing leg design for Mars yet, they're expected to share more details soon, especially as the timeline for the first uncrewed Starship mission to Mars is approaching, possibly within the next 2 years. Mars has stronger gravity than the Moon and a surface that's far more unpredictable, rocky, dusty, and full of elevation changes. That means Starship will need a more robust and flexible landing system to handle those challenges safely. Like Dr. Firuz Naderi from NASA once said, landing on Mars is like climbing Mount Everest. No matter how skilled you are, you're going to lose your balance at some point and fall. So be careful. Check, recheck, test, retest, and then let someone else check it all over again. On Earth, a Starship can shed up to 99.9% of its orbital velocity just by re-entering the atmosphere, gradually slowing down before the final landing burn. That means it only needs a small amount of fuel for the flip maneuver and touchdown, just around 90 meters per second when it performs the landing flip near the surface. On Mars, things are a lot tougher. Starship can only lose about 99% of its orbital speed through atmospheric drag, which leaves it falling at roughly 450 meters per second, 5 times faster than on Earth. This difference comes from Mars having an extremely thin atmosphere, only about 0.6% the pressure of Earth's. With so little air resistance, the atmosphere can't do much to slow the vehicle down. While Earth's thick atmosphere handles most of the braking before the engines need to fire, on Mars, Starship has to rely much more on engine thrust to make up for the remaining speed. Even though Mars only has about 38% of Earth's gravity, meaning Starship weighs less during descent, the higher speeds and thinner air still make the landing much more challenging. The engines have to fire with extreme precision and enough power to slow the vehicle down safely, and the landing legs must deploy perfectly, adding more complexity to the whole process. Landing legs of Starship aren't just there for space missions. They also make a huge difference when it comes to military applications and heavy transport. Imagine a future where the global population has exploded past 20 billion. Mega cities are collapsing under the weight of overcrowding and dwindling resources. Tensions are high, and all over the world, conflicts are breaking out over water, over food, over land. Wars, both big and small, become a constant. In times like these, military operations are more critical than ever to keep key regions secure. And Starship. It's faster than any military truck or jet. A military-grade Starship can carry around 100 people, along with hundreds of tons of food, medical supplies, and weapons, ready to deliver them to any battlefield, no runway needed. Even in the middle of a war-torn zone, the ship touches down with ease, its smart landing legs deploying automatically to handle the rough terrain. The hatch opens, and a military rescue team rushes out, immediately backing up troops still holding the line. The wounded are quickly loaded into the ship, treated inside a specially designed medical bay with cutting-edge equipment. Then more Starships begin to land, one after another, forming a massive forward base. Their ultralight advanced armor plating shields them from enemy fire, turning the battlefield into a scene straight out of a sci-fi movie. With its engines roaring, Starship lifts off just minutes later, cutting through the thick smoke and carrying hundreds of lives to safety. In a world where order has completely collapsed, Starship isn't just a machine. It's a symbol of survival, the last bridge connecting hope to what's left of humanity. For now, that's just a vision. Reality looks different. Most governments are still managing population growth, while countries like Germany, Italy, Japan, or Spain grapple with aging populations instead. But if that worst-case scenario ever comes true, SpaceX and Starship will be more ready than ever to rise to the challenge, thanks to its massive cargo capacity and a smart landing system that can lock onto almost any terrain. Unbelievable, after just 2 recent test flights of Starship version 2, Elon Musk has already declared that version 3 could launch later this year. And it's also expected to break multiple spaceflight records, pushing SpaceX to an entirely new position. So, how is that even possible? This year marks a major milestone for Starship, as SpaceX officially rolled out version 2, with a series of major upgrades. But after just 2 test flights, Flight 7 and Flight 8, things didn't quite go as planned. Still, as the saying goes, failure is the mother of success. These early setbacks could serve as a launch pad for a more refined Starship 5-2, paving the way for an even bolder leap forward, and that leap is Starship version 3. It's no longer just a concept. This next-gen vehicle is already in active development. Even Elon Musk himself has confirmed it. Back in November last year, Musk posted on X saying, "Current Starship is more than twice as powerful as the Saturn V moon rocket. Starship V3, which hopefully flies in about a year, will be 3 times more powerful." That's completely true. At the time, Starship version 2 was still a work on progress, but in terms of raw power, the 33 Raptor 2 engines on the Super Heavy booster were already generating around 7,590 tons of thrust, more than double what the Saturn V's booster could produce, which was about 3,400 tons. Also, unlike the old Saturn V booster that was used only once, Starship's booster is built to be fully reusable. And if everything goes according to plan, Flight 9 could be the first time we actually see that happen, with Booster 14 making a comeback after flying on Flight 7. That would be a huge step forward. More importantly, Musk said Starship version 3 could be ready to fly within a year, meaning SpaceX is aiming to finish it before year's end. Still, that timeline won't be easy to meet. Building version 3 isn't just about upgrades. SpaceX needs to redesign it from the ground up. Why? Because this version is expected to reach 150 meters tall, featuring much larger propellant tanks across both stages. It'll be powered by 33 Raptor 3 engines, each producing 330 tons of thrust. No wonder version 3 is targeting triple the power of Saturn V. It's also expected to take on more complex missions in the future, things like on-orbit refueling, deep space flights, and maybe even stepping in as a space station replacement once the ISS retires around 2030. And like I said, that timeline's a stretch. Finishing something this massive in a year is a long shot, with problems that won't be solved overnight. To turn Starship V3 into reality, SpaceX will first have to tackle several major challenges. First, Starship V3 includes the Super Heavy booster, which already stands at 80.2 meters tall, and the Starship itself, reaching an impressive 69.8 meters. Given those massive dimensions, the first thing SpaceX needs is to expand and upgrade its production facilities. Take the high bay, for example. It currently doesn't have the height to support construction of the new vehicle. To solve this, SpaceX is tearing it down and replacing it with a much larger facility called the Gigafactory. It's being designed specifically to accommodate the increased size and volume of the next-gen Starship. This upgrade will also speed up the stacking process and allow multiple prototypes to be assembled simultaneously. Second, Launchpad A wasn't built to handle the size or complexity of Starship V3. It works fine for V2, but it falls short in terms of height, structural strength, and integration capabilities needed for a much bigger vehicle. SpaceX is also developing Launchpad B, with several major upgrades, a taller tower, better stacking systems, and a flame trench under an updated orbital launch mount. These improvements are meant to boost both safety and efficiency during launches. That said, the setup is still mainly optimized for V2. As V3 continues to grow in scale and complexity, more changes may be necessary, like extending the tower even further or fine-tuning the integration system. At some point, SpaceX might even need to build an entirely new launch pad to fully support the next generation. Next comes the issue of supply, everything from materials to manpower. As of April 9, 2025, new import tariffs of up to 125% have gone into effect for goods from certain countries, putting added strain on U.S. manufacturing. For SpaceX, this could drive up the cost of critical parts and raw materials needed for Starship version 3. To stay on schedule, the company may need to adjust its supply chain, sourcing more components domestically, or finding alternative suppliers to avoid delays and budget overruns. On the workforce side, building V3 is a much more complex challenge. It'll take a larger team, more engineers, technicians, and assembly crews, possibly hundreds or even thousands of new hires at Starbase and McGregor. That kind of growth also calls for expanded housing and better infrastructure to support the team in such a remote area. On top of that, there are still plenty of less visible but critical challenges, like redesigning ground systems, scaling up manufacturing, updating software, and validating new hardware. All of that takes time. So realistically, Starship version 3 probably won't debut this year. With how things are moving, mid-2026, maybe sooner if everything goes smoothly. So yeah, those are some real challenges SpaceX has to deal with. But there's no need to worry. Every problem has a solution, especially when you're talking about the company that built the Falcon 9, the Dragon capsule, Falcon Heavy, and now Starship version 2. That kind of track record gives no reason to think they can't pull off version 3. It's just going to take a little more time, testing, and refinement to get it right. And honestly, the wait is worth it. This isn't just another vehicle, it's something that could go down in history. A legendary ship built to do the impossible. Elon Musk had promised this, and recently he made a strong statement about Starship 5.3. He said, "We are honing in on the V3 Starship design. SpaceX is tracking to a Starship launch rate of once a week in approximately 12 months. That will yield approximately 100 tons to Starlink orbit with full reusability. Profound breakthrough." That's right. Even though SpaceX has only flown 2 V2 missions and hasn't built many prototypes yet, the company is already moving full speed ahead with V3 development. And that's a big deal because V3 isn't just a minor upgrade. It's expected to bring massive leaps forward for the entire Starship system, helping SpaceX achieve world-first milestones we've never seen before. One of the first major milestones it's set to achieve is becoming the largest rocket ever built. Starship version 2 was designed to provide enough space, around 1,000 cubic meters, to carry about 100 people, or roughly 10 cubic meters per person. But version 3 is expected to push that even further, featuring an expanded payload volume of around 1,200 to 1,300 cubic meters. If that same ratio holds, it could carry 120 to 130 passengers, a staggering number no other spacecraft has ever come close to. Next, according to Musk, SpaceX is aiming for a Starship launch every single week. That's around 52 launches a year. To pull that off, the rocket has to be fully reusable, with no major failures like we've seen in version 2. Moreover, the supply of liquid methane and liquid oxygen needs to stay steady and uninterrupted. Still, if they can make it happen, that kind of launch cadence would be a massive achievement, one that even countries like China or India haven't come close to matching. It would also prove that the company is operating with incredible precision across every single system, a rare feat in such a high-risk industry. Another big deal is the massive leap in payload capacity. Alongside all the technical upgrades, Musk also revealed a major breakthrough for V3. It's expected to deliver around 100 tons to Starlink orbit with full reusability. That's right. Thanks to bigger fuel tanks and more powerful engines, Starship is getting a serious boost in what it can carry. To put that into perspective, a typical Falcon 9 launch currently deploys just over 20 Starlink 5 2.0 satellites, which works out to about 16 to 23 tons per launch. But once Starship 5.3 is fully operational, that number is expected to skyrocket, up to 5 times higher. It'll massively accelerate the expansion of the Starlink constellation. So, in the future, it's easy to see why Falcon 9 will eventually be completely replaced by Starship. In addition, Dr. Lisa Watson-Morgan, NASA's Human Landing System Program Manager, revealed that Starship version 3 will feature dedicated hardware specifically designed for refueling operations, including advanced docking mechanisms and quick disconnect systems. These components, which are not present in version 2, are essential for safely and efficiently transferring cryogenic propellants, further boosting Starship's capabilities for deep space missions. Clearly, version 3 is much better suited for orbital refueling tasks. And when that happens, it'll mark a historic first, becoming the world's first spacecraft to function like a gas station in space. Overall, when you stack Starship up against its competitors, it pretty much leaves them all in the dust. Take NASA's Space Launch System, for instance. Sure, it pulled off a successful Artemis 1 mission, and that's great. But here's the catch. It's a single-use rocket. Each launch costs about $4 billion, and none of it is reusable. That's a massive price tag for just one flight. With that same amount of money, SpaceX could launch Starship anywhere from 100 to 200 times. Kinda mind-blowing when you think about it, right? Next up is New Glenn, Blue Origin's new rocket. It's an impressive machine, standing 98 meters tall, but still over 50 meters shorter than Starship version 3. Powered by 7 BE-4 engines, it can haul about 45 tons to low Earth orbit, or just 13 tons to geostationary orbit. Each launch is estimated to cost between $100 million and $200 million, and the projected annual pace is just 10 to 20 launches, far behind Starship's target of 52. At that rate, it's not even in the same league as Falcon 9, let alone Starship. So, aside from those achievements, what else will this new version of Starship bring to SpaceX? Of course, in business, it always comes down to profit. And thanks to version 3, SpaceX stands to save and earn a whole lot more. Normally, a Falcon 9 launch for internal missions like Starlink costs around $30 to $40 million. But using Starship, that number could drop to just $10 million, or even less. On top of that, it can carry up to 5 times more satellites per flight. So, in the long run, it's not just about cutting costs, it's a game-changing leap that boosts profits and scales efficiency. Because of that, SpaceX is quickly becoming the go-to choice for countries looking to launch satellites. Lower prices, proven reliability. Why choose a pricier competitor unless they can somehow top the trust Musk's team has already built? SpaceX recently secured a $5.9 billion deal from the U.S. Space Force, officially making them the Pentagon's top launch provider. This year alone, they've landed most of the government's highest-value launch contracts. It seemed like we were on the verge of witnessing the Starship Flight 9 launch. But the harsh reality is that SpaceX has revealed several issues that could delay the mission until the end of April or longer. Why? When exactly will Starship Flight 9 launch? SpaceX kicked off April with a major milestone that had Starship fans buzzing. On April 3rd, Booster 14 roared to life in a successful static fire test, the first time SpaceX has ever reused a Starship booster. It was a powerful, flawless test that sparked hopes Flight 9 was just around the corner. For a moment, it felt like the countdown had truly begun. But here we are, days later, and things have gone quiet. Since that fiery test, there's been little visible movement at Starbase. No new tests, no loud engine rumbles, not even the usual flurry of activity we've come to expect during a launch buildup. The most noticeable development? Booster 14 was lifted off the orbital launch mount and transported back to Mega Bay 1 for further inspection. Well, as with everything Starship, there's more going on beneath the surface. Booster 14 still has a long checklist ahead. Once it's back in the hangar, it needs a thorough inspection, especially of its 33 Raptor engines. SpaceX learned the hard way in earlier flights that cutting corners here can cause serious issues. This inspection phase alone could take several days or longer, depending on what engineers find. After that, critical hardware still needs to be installed. We're talking about the Hot Staging Ring and Flight Termination System, FTS, neither of which are quick plug-and-play jobs. The hot staging system in particular is under the microscope right now. Engineers suspect that the clamp ring used during staging may have contributed to recurring second-stage problems in Flights 7 and 8. If redesigns are needed, that could stretch timelines even further. Meanwhile, the upper stage for this mission, Ship 35, has been out of action too. It was rolled back to the production site way back on March 13th and hasn't been spotted moving since. Another road closure on April 8th sparked some hope that S-35 might finally be heading back to the launch site, but it looks like that window was used for Booster 17 instead, likely for cryogenic testing. No movement on S-35 means no static fires, and that's a big deal. After the upper stage problems in the last 2 flights, SpaceX is expected to run multiple static fire tests on Ship 35 to make sure everything's solid. Once that's done, it'll go through another detailed post-test inspection before it's cleared for integration. Assuming both stages make it back to the pad, one major hurdle still remains. The wet dress rehearsal, this full-scale countdown simulation, is designed to test all systems, fueling, pressurization, countdown procedures, without actually igniting the engines. SpaceX skipped the WDR before Flight 8, and that may have contributed to the abort and technical issues during the countdown. This time, it's almost certain they'll bring it back to the checklist. Given recent troubles, double-checking everything before launch is just common sense. Then there's the investigation into Flight 8, which is still open. While Flight 7's case has been closed, the similarities between the two missions might speed things up. That said, having an open investigation during launch prep can be a distraction and potentially force late-stage changes if the findings are significant. Technically, SpaceX can launch while an investigation is still active. But, let's be honest, if something needs fixing, they're going to fix it before lighting those engines again. So, when will Flight 9 launch? That's the question everyone's asking, and the answer is becoming less clear by the day. Elon Musk had once thrown out a 4 to 6 week turnaround from Flight 8, suggesting a mid-April launch. But now that's no longer optimistic. Even his "coming up soon" post on X after the B-14 static fire lacked the usual confidence. He didn't specify a clear launch date, instead giving a vague time frame. Some fans had hoped for a symbolic April 18th launch, but even that is now starting to look unlikely. At this point, Starship Flight 9 will definitely not be able to launch this month. May is emerging as a potential target, though. Like with anything rocket-related, it's all subject to change. Starship is a beast of a rocket, and rushing it isn't just risky, it's reckless. Look, delays are disappointing. We get it. But after 2 upper stage failures in a row, SpaceX simply can't afford another major setback. Every extra day spent inspecting, testing, and double-checking increases the odds of a successful flight. This is how SpaceX operates: fail fast, learn faster, and come back stronger. We've seen this play out time and time again. So, even if Flight 9 isn't launching this week, or next, or even this month, it's still coming. And when it does, it could be the most important Starship mission yet. Although the development of Starship has posed some challenges for the company, SpaceX as a whole continues to grow rapidly within the aerospace industry. In just 2 decades, the company has managed to surpass former aerospace giants like Boeing, Lockheed, and Northrop Grumman to achieve a near monopoly on rocket launches in the United States, accounting for 87% of the nation's orbital launches in 2024. Since the mid-2010s, the company has dominated NASA launch contracts and become a primary contractor for the Pentagon. Today, it also serves as a launch provider for commercial clients, having delivered numerous satellites and 5 private crewed spaceflights to orbit, with more on the way. Other space companies have struggled to compete for years, as developing a reliable rocket demands slow, steady work and a substantial budget. There are a few reasons why SpaceX was able to cement its position in the space industry. When it began in the 2000s, it had 3 consecutive rocket failures and seemed poised to fold, but it barreled through with Musk's financial support, and later, with a series of NASA and defense contracts. It has been a primary beneficiary of NASA's commercial space program, developed in the 2010s with the intention of propping up the industry. SpaceX has also effectively achieved a high degree of vertical integration, Sampson points out. It owns almost all parts of its supply chain, designing, building, and testing all its major hardware components in-house, with minimal use of suppliers. That gives it not just control over its hardware, but considerably lower costs. And the price tag is the top consideration for launch contracts. The company was also open to taking risks that other industry stalwarts were not. I think for a very long time the industry looked at spaceflight as something that had to be very precise and perfect, with not a lot of room for tinkering, says Chris Combs, an aerospace engineer at the University of Texas at San Antonio. SpaceX was really willing to take some risks and accept failure in ways that others haven't been. That's easier to do when you're backed by a billionaire. Today, several companies are targeting SpaceX's Falcon 9, which can carry up to 20,000 kilograms to orbit, and is used to launch multiple satellites or the crewed Dragon spacecraft into space. There is a practical monopoly in the medium-lift launch market right now, with really only one operational vehicle, says Muriel Baker, a spokesperson for Rocket Lab, a US-New Zealand company. Rocket Lab plans to take on the Falcon 9 with its Neutron rocket, which is expected to have its inaugural flight later this year from NASA's Wallops Flight Facility in Virginia. The effort is building on the success of the company's smaller Electron rocket, and Neutron's first stage is intended to be reusable after it parachutes down to the ocean. Another challenger is Texas-based Firefly, whose Alpha rocket can be launched from multiple spaceports so that it can reach different orbits. Firefly has already secured NASA and Space Force contracts, with more launches coming this year, And on March 2nd, it also became the second private company to successfully land a spacecraft on the Moon. Next year, Relativity Space aims to launch its first Terran R rocket, which is partially built from 3D printed components. And the Bill Gates-backed Stoke Space aims to launch its reusable Nova rocket in late 2025 or, more likely, next year. Competitors are also rising for SpaceX's Falcon Heavy, holding out the prospect of more options for sending massive payloads to higher orbits in deep space. Furthest along is the Vulcan Centaur rocket, a creation of United Launch Alliance, a joint venture between Boeing and Lockheed Martin. It's expected to have its third and fourth launches in the coming months, delivering Space Force satellites to orbit. Powered by engines from Blue Origin, the Vulcan Centaur is slightly wider and shorter than the Falcon rockets. It currently isn't reusable, but it's less expensive than its predecessors, ULA's Atlas V's and Delta IV, which are being phased out. Mark Peller, the company's senior vice president on Vulcan development and advanced programs, says the new rocket comes with multiple advantages. One is overall value in terms of dollars per pound to orbit and what we can provide to our customers, he says. And the second is versatility. Vulcan was designed to go to a range of orbits. He says more than 80 missions are already lined up. Vulcan's fifth flight, slated for no earlier than May, will launch the long-awaited Sierra Space Dream Chaser, a spaceplane that can carry cargo and possibly crew to the International Space Station. ULA also has upcoming Vulcan launches planned for Amazon's Kuiper satellite constellation, a potential Starlink rival. Meanwhile, though it took a few years, Blue Origin now has a truly orbital heavy-lift spacecraft. In January, it celebrated the inaugural launch of its towering New Glenn, a rocket that's only a bit shorter than NASA's Space Launch System and SpaceX's Starship. Future flights could launch national security payloads. Competition is emerging abroad as well. After repeated delays, Europe's heavy-lift Ariane 6 from Airbus subsidiary Ariane Space had its inaugural flight last year, ending the European Space Agency's temporary dependence on SpaceX. A range of other companies are trying to expand European launch capacity with assistance from ESA. China is moving quickly on its own launch organizations too. They had no less than 7 commercial space launch companies that were all racing to develop an effective system that could deliver a payload into orbit. Kari Bingen, director of the Aerospace Security Project at the Center for Strategic and International Studies, says of China's efforts, "They are moving fast and they have capital behind them, and they will absolutely be a competitor on the global market once they're successful and probably undercut what US and European launch companies are doing." The up-and-coming Chinese launchers include Space Pioneer's reusable Tianlong 3 rocket and Cosmoliep's Yueqian rocket. The latter is to feature a chopstick clamp recovery of the first stage, where it's grabbed by the launch tower's mechanical arms, similar to the concept SpaceX is testing for its Starship. The competition may be fierce, but catching up to SpaceX will be no easy task. Boeing's Starliner successfully flew astronauts to the ISS on its first crewed mission in June 2024, but after a thruster malfunction, the crew became stranded at the orbital outpost for 9 months. Meanwhile, Blue Origin's New Glenn reached orbit as planned, but its first stage failed to land successfully, and the upper stage remained in orbit. Any company faces both technical and financial challenges. Boeing is reportedly considering selling parts of its space business following the Starliner setback and ongoing issues with its 737 MAX aircraft. Virgin Orbit, the launch spin-off from Virgin Galactic, shut down in 2023. Another issue confronting SpaceX's potential commercial rivals in the US is a complex and uncertain political environment. While Musk doesn't oversee SpaceX's day-to-day operations, he remains closely tied to Doge, a Trump-era initiative that continues to influence the workforce and budgets of NASA, the Department of Defense, and other space-related regulatory agencies. Regardless of the political climate, commercial competition is certain to heat up throughout 2025, but SpaceX already has a significant head start. That's all for today's episode. Thank you so